Hi guys, this is Steven. Welcome back. Today we're going to talk about the four great beasts of physics. Before you click away, please stick with me for a few minutes. I promise this is going to be really interesting, and I will speak quickly so I won't waste your time. Okay, in this video, let's start with the famous paradox of Zeno's tortoise. Imagine that you are having a job interview and the interviewer asks you this question. If a rabbit and a tortoise are having a race, and as I say rabbit, as I say tortoise, the rabbit runs at 10 meters per second, while the tortoise moves at 1 meter per second. But this tortoise has a 9-meter head start. The question is that when will the rabbit catch up? You might quickly figure out the answer, right? It's pretty simple. But back in the ancient Greece, Zeno would tell you that the rabbit would never catch up to the tortoise. Sounds crazy, doesn't it? Well, let's dive in and see why this happens. Here's how the story goes. The race starts and the tortoise has a head start, and this rabbit is going to chase the tortoise. The rabbit reaches the spot where the tortoise stopped, but by then the tortoise has moved a little further ahead. Next, the rabbit reaches a new spot where the tortoise was, but again the tortoise has moved a little further. The process repeats over and over, and every time the rabbit gets to where the tortoise was, the tortoise has moved a tiny bit further. So it seems like that the rabbit can never actually catch up to the tortoise. You and me, we are living in 21st century. It is very easy for us to understand the concepts of limits and infinity. But imagine if we were in ancient Greece over 2,000 years ago. If I had an infinite number of numbers to sum up, I would naturally think that the total sum is infinitely large. So when Zeno came up with his paradox, it really blew people's minds. The idea that the rabbit could never catch the tortoise seemed completely against our common sense. Now let's jump back to today. We have tools to understand this puzzle. What's happening here with the rabbit and the tortoise is creating what we call an infinite sequence, which is a series of steps that goes on forever. But here's the cool part. Even though there are infinite steps, the distance that the rabbits need to cover can still be a finite number. This is where the concept of limits comes in. A limit helps us figure out how even an infinite number of tiny steps can add up to a finite specific distance. It's like cutting a pizza into infinitely many tiny slices. No matter how small the slices, you still get the whole pizza. By understanding limits, we can see that the rabbit does eventually catch up to the tortoise, even though it takes an infinite number of tiny steps to get there. So what can we learn today? First, it shows us that our intuition and common sense are not always right. For example, like Benford's law, multi-hole problem, and birthday paradox. Okay, and birthday paradox is quite interesting. It says that in a room with 23 people, the probability that at least 2 of them share the same birthday is over 50%. So don't just rely too much on our intuition and common sense. We need to look deeper and think differently to solve the complex problems. Second, let's talk about some interesting stuff related to limit and convergence. I like that. I really like that. Imagine that an investor who makes trade, and each trade could be based on rational decisions or irrational hunches. Whether the trade is rational or not, it might make money, just with two different probabilities. But if it makes money, the investor is likely to repeat the behavior, whether it's rational or not. It makes sense, right? So the question is that over the long term, will this investor's trading behavior converge to a stable pattern? Okay, actually, I've worked on a math model to study this question, and it's fascinating. It's really fascinating. If you want to know my conclusion, just comment below to let me know. Let's stay tuned for that. Okay, thanks for watching. We've just explored Zenos Tortoise, and there are other three great bits of physics to go. Laplace's demon, Maxwell's demon, and Schrodinger's cat. Just comment below to let me know which one you'd like to see next. And I will work on getting that out of video soon. See you in the next video. Bye bye.